Hi, for this recording, I will show you how to find the limit of x times ex minus sin x over 1 minus cosine 2x as x approaches 0. Now notice that when x approaches 0, what will happen on the numerator and denominator? As a rough work, you'll find that when x approaches 0, you get 0 times e power 0, right? 0 times e power 0 minus sin 0, and what do you get? You get 0, right? And 1 minus cosine of 0, you get 1 minus 1, also 0. So this is actually a 0 over 0 case. So if this is a 0 over 0 case, in order to find limits, we know we cannot find 0 is divided by 0 is undefined. So you have to use the L'Hopital rule. Of limit. So what is the L'Hopital rule of limit? It says that if f and g are differentiable on an open interval I containing the point C, at which fc and gc equals 0. In this case, the c is equal to 0 now. And then the limit of fx over gx when x approaching c exists and equal to limit of f prime x over g prime x when x approaching c, provided the last limit exists. So now let's look at the question and see how we do the problems. So this is what we're going to find. The limit is a ratio of two functions. Let's numerator be fx and denominator be gx. So fx is xex minus sin x, and gx is 1 minus cosine 2x. Now both f and g are differentiable on the interval. The interval in this case is from minus infinity to infinity. And the c is equal to 0 now. So f of 0 and g of 0 both equal to 0 as I showed you earlier. So this satisfies the condition of, so in this case you can say f and g satisfy a condition of L'Hopital rule. So limit of fx over gx when x approaches 0 is equal to limit of f prime x over g prime x when x approaches 0. Now what is f prime x over g prime x now? And the later limit, if the later limit exists, then you can find the answer. Now fx is xex minus sin x, so you have to use the product rule now. So let's show you the working. So I have fx equal to xex minus sin x here. So for the first term, you have to use the product rule. You keep the first term, differentiate the second term, plus keep the second term, differentiate the first term as using the product rule, and minus differentiate sin x to get cosine x. So you know that differentiate x over ex, e power x to get ex here. Differentiate x alone and get 1 minus cosine x, and this is how I get the f prime x here. And since gx equal to 2 cosine 2x, 1 minus 2 cosine 2x, right? Gx is 1 minus cosine 2x, sorry, right? Gx 1 minus 2, 1 minus cosine 2x without a 2 there. So in this case, alright, so gx is 1 minus cosine 2x, so g prime x here is equal to, differentiate 1 you get 0, differentiate cosine x you get minus sin x minus sin 2x, and differentiate 2x to get a 2, and that is how you get right. So in this case, 1 minus cosine 2x is your gx here. So differentiate cosine x to get minus sin x. Right, so in the end, g prime x is equal to 2 sine 2x. Okay, so g prime x equal to sine 2x here. So this is g prime x 2 sine 2x here. So now apply the L'Hopital rule again. Now f prime and g prime satisfy above continuous differentiable on the interval from minus infinity to infinity. And f prime and 0 and g prime 0 equals 0 because f prime and 0 is equal to 0 e0 plus e0 minus cosine 0. Now cosine 0 times e0 is 0, cosine 0 is 1, cosine 0 is 1, e power 0 is 1, so this is again 0. Now g prime of 0 is equal to 2 times sine of 2 times 0 is also sine 0, 2 times sine 0 is 0 again. So that is why f prime 0 and g prime 0 is also equal to 0. So f prime and g prime satisfy a condition L'Hopital rule at 0 again. So we know that the limit is equal to x approaching 0 f double prime over g double prime, provided that little limit exists now. So now what is f double prime, g double prime? Now let's work out again. So now we know f prime just now was x ex plus ex minus cos x here. So applying the result we obtain, we differentiate one more time. F double prime x is equal to x, opening product rule, differentiate ex, you get ex, keep the first term, differentiate second term, you get ex, then differentiate ex again, you get ex. So this is how you differentiate the x ex again, right? So when you differentiate x ex, you get this thing, and when you differentiate ex, okay, when you differentiate ex, then you get e back ex again, and differentiate minus sine x, I will get, if I differentiate minus sine x, I get minus sine x, minus differentiate cos x, minus sine x here. So you get x ex plus 2 ex by ex here plus sine x, and this is how you get f double prime x. Now g double prime x, as g prime x equal to 2 sine 2x, so g double prime x is equal to 2 cosine 2x, then times 2 again, so you get 4 cosine 2x. Alright, so g double prime x is 4 cosine 2x here. Now both f double prime x and g double prime x are continuous function. So happen that when x approaches 0, f double prime 0 is equal to 0 e power 0 plus 2 times e power 0 plus sine 0, which is equal to 2, and g double prime 0 is equal to 4 cosine 0, which is equal to 4. So now, as f double prime 0 is continuous, so this is equal to f double prime 0 over g double prime 0 now by the combination rule, and so the answer is half. This finish the recording, because we can conclude now the original limit is equal to half after we apply the L'Hopital rule.